Imagine uncovering a secret hidden within one of the most iconic paintings of the 20th century, only to realize it's now off-limits forever. That's exactly what happened when scientists recently identified a rare blue pigment in Jackson Pollock's No. 1A, 1948, a masterpiece that epitomizes his revolutionary drip and splash technique. But here's where it gets controversial. The pigment known as manganese blue has been discontinued for decades due to environmental and health concerns. So while we now know what Pollock used, replicating it today would be nearly impossible and ethically questionable. But why does this matter? Jackson Pollock, the American pioneer of abstract expressionism, is celebrated for his chaotic yet mesmerizing style. His paintings, like No. 1A, are a whirlwind of color and movement, but until now, the exact chemical origin of the vibrant blue in this piece remained a mystery. Researchers turned to laser spectroscopy, a cutting-edge technique that examines matter at the atomic level, to solve it. Their findings, published in the journal PNAS, confirm Pollock's use of manganese blue, a turquoise-ish pigment, first discovered in 1907 and patented in 1935. It was a favorite among artists until its phase-out in the 1990s, leaving modern conservators with a unique challenge: how to preserve a color that can no longer be produced. And this is the part most people miss. Pigments and hues aren't the same thing. Manganese blue, chemically known as barium manganate, Vi sulfate, is a specific compound that creates its distinctive color. However, the hue we see, the shade of blue, can be replicated by mixing other pigments. For example, combining a blue and yellow pigment creates a green hue, not a green pigment. This distinction is crucial for artists and conservators alike, as it highlights the complexity of preserving and recreating historical works. The chemistry behind manganese blue is equally fascinating. According to Edward Solomon, a chemist from Stanford University, the pigment's blue color arises from the way its molecules absorb light. Specifically, when light hits the pigment, an electron moves from an oxide ion to a manganese ion, absorbing purple and green light and reflecting the blue we see. But what's the practical value of identifying this compound? Abed Haddad, a conservation scientist at MoMA, explains that knowing the exact pigment helps conservators develop better preservation strategies. Many pigments degrade under certain environmental conditions, such as intense light or humidity, and understanding their chemistry ensures they're displayed and treated safely. Here's the bold question. Should artists today be more transparent about the materials they use, knowing future generations will struggle to preserve their work? Pollock left no record of his pigments, leaving scientists to play detective. If you're an artist, consider this a friendly nudge. Leave a record of your materials. Future conservators will thank you. And for the rest of us, this discovery raises a thought-provoking debate. How do we balance artistic freedom with the long-term preservation of cultural heritage? Share your thoughts in the comments. Let's spark a conversation.